Hi, everyone. I have a post-lunch hour, so post-afternoon, so everybody might be a little asleep. I'll try to wake you up with probably the worst title of all the talks, which is Auditing, Access, and Automation with Even More Automation. And the reason why I thought about this so much is that I do a lot of automation, of course. And my automation cycle tends to look a little bit like this. I identify a functional issue. I recognize and remediate that there's a functional issue going on with my automation, whether it be, I don't know, the script isn't actually as idempotent as I thought, something like that. And then I implement some more automation to fix that. This could be either something that was done manually before, and I was like, you know what, I want to do this automated, or maybe it was something wrong with my initial automation in the first place. So this automation cycle, we've gotten used to. People used to be afraid of this, right? Because the idea was that maybe you wrote it wrong and maybe you couldn't fix it. Maybe you did something absolutely disastrous. But the reality is, I think we've gotten used to this automation cycle by now, because if you're in this room, you're probably thinking to yourself, all right, well, we're trying to deploy quickly. We're trying to operate really quickly, securely, and reliably. All these things, right? We want to be able to fulfill all of these criteria, but we stop. We don't really deploy or operate quickly anymore when we find some anomalous activity. It kind of exists in this weird space where you can be automating and you could be doing all of these things quickly, securely, and reliably. And then when you find something wrong, everybody stops. You put it all down and you try to identify what is happening, who did it, or who is it affecting, and where it's coming from. So a good example of this, for better or for worse, is that in some situations, we all find a crypto miner on occasion in our infrastructure, where I know I see some giggling there, but yeah, we've all found it. And it's like nothing that stops your mortality, stops and makes you think about your own mortality when you realize, oh no, there's something in my infrastructure that's not supposed to be there. And now you have to figure out how to remediate it. And if you've automated well, it's not so hard to go back and fix the issue. But if you haven't, then, you have to go through this process of reconstructing and resolving what happened and identifying how that actor got into your system. So it's not that necessarily we have this problem from a security standpoint, right? The point is, when you automate, you need to know what is going on with your automation. Otherwise, you don't know if it's actually doing what you expect it to do or not. So at HashiCorp, we do use Datadog for our managed cloud services to identify, well, what's going on with our automation. It's kind of funny, and the reason why the title is Automating Your Automation with More Automation, because for us, well, we have a bunch of automation tools at HashiCorp, and we use our own tools, and we actually have to know what's going on with the tools. So in order to identify what's going on, we have to have some kind of application performance monitoring, as well as other monitoring systems to understand how these managed services work. So I'm not going to go into that today. We're going to take a little bit of a different take, something we don't really do, right? I'm going to look at it from a security standpoint. Why am I changing this? Why am I going from observability of automation to specifically observability of security in automation? Well, it all happened because I was working with a bunch of engineers and they were like, hey, couldn't we just do the same thing for security? And I was like, actually, you could. And the automation cycle with security is pretty much the same as the automation cycle on its own, right? You identify a security issue, you recognize and remediate that there's a problem, and you fix the automation with respect to that security issue. So for our canonical example of the crypto miner in there, you identify that there's a security issue, right? A miner's in your system, you recognize and remediate that, and then you fix it, right? So either you either quarantine that part of the system, you identify how did it get there, what's going on, you fix that, whatever your security vulnerability might be, and then you go through the cycle again and again. You don't have to stop, right? But it's not really a matter of stopping. It's speeding this cycle up. You heard it all throughout today, right? Which is, how do you speed up your automation, right? And how do you speed it up when there's a security issue or there's something you have to solve that has a really high impact across your system? Well, it turns out that a time to resolution for automation in general is pretty fixed, right? Fixing the automation is a pretty well-established level of effort. If you've done an estimation for how long it will take you to fix that automation, it's pretty much, for the most part, one kind of capacity planning, right? But when you look at it from a time to resolution from an observability standpoint, meaning what you're looking at, well, identifying the security issue and recognizing and remediating the problem is a much, much more difficult problem to look at, right? Because that's actually where the bulk of your time is being spent. You're trying to reduce the time for these stages specifically. So how do you compress the identification of security issue and then recognize and remediate it quickly? That's the question we're going to answer today. And in order to answer this question, in order to have the solution of compressing the amount of time it takes you to identify the problem and then remediate it, you need to observe your automation for security. Kind of interesting, right? But what do you observe? Because security and automation can mean a lot of different things. And I'm here to tell you that it actually boils down to one thing. Automation is about access. Automation, yes, is about functionally taking something that's manual and making it more automated. But at the end of the day, from a security standpoint, automation is all about access. Because when you think about it, automation needs access to everything. Take a deployment pipeline, for example. It checks out code, it needs access to version control. If you're deploying the application, it needs access to platform or release repositories. If you're checking your code quality, you need access to a quality assurance tool. So you're either getting access to other systems from a deployment pipeline, which is a piece of automation, or you're trying to manipulate other systems. And that's the problem with automation. It needs lots of access. So why do you need to observe access? Or more importantly, why do you need to audit access across your system? Well, first, you need to observe service interactions. What's important to understand about service interactions is that we don't always know how our systems are accessing each other, especially when you're scaling those systems. It's impossible to keep track of the millions of requests that are happening, whether it be from between services or services to other managed providers. There's also a question about maintaining least privilege. We've talked about this over and over from a security standpoint, but what does it really mean? Well, least privilege is always evolving. It means that a system has the minimum access it needs to do what it needs to do. In automation, we've all done this. I don't need to raise a hand, but we've all done this where in automation we said, whatever, we'll just give it admin access. So that way it can deploy what it needs to and get things done. That's not least privilege. We can all acknowledge that. Take a moment. But the idea is that it's really hard to maintain this over time. So it's auditing access is about understanding what does least privilege even look like. Then it's about identifying and mitigating a blast radius for it, right? Because if your automation has a very large blast radius, it means that someone can take advantage of that automation to do something more malicious. And finally, standardizing event information. I think this is where it's really powerful from an observability standpoint, but also thinking about auditing from the perspective of observability is also very important. Events in your system have to have the right and the most valuable information for you to understand what's going on. So if you're auditing your access, think about standardizing event information for it, right? So all of these things contribute to how to think about observing security in automation. All right. I talked a lot about this theoretically. Let's take a more tangible example. I'm going to talk about application deployment because this is probably one of the more common use cases from an automation standpoint. How do you deploy an application? Well, you can all argue about this, but I do hear the idea that local testing is a form of automation, right? If you're a developer or you are working with developers, you'll notice they do a lot of unit tests or they do a lot of testing locally. That in itself is a form of automation to accommodate for. You also have integration testing. At the end of the day, someone needs to test out whether or not systems can interact with each other, right? So integration testing becomes a good portion of automation as well. And then there's production. We focus a lot on production from a security standpoint and from an access standpoint. That's because the stakes are pretty high from production. But we actually have a lot more problems existing in the local environments as well as in development environments. So across the board, you have to look at your access from an automation standpoint across all of these systems. So let's talk about local testing first. This is the one that I think from a security standpoint, it's a little bit harder to think about because anytime you're adding another layer of security to someone who's trying to build an application, well, it's friction, right? You don't want to increase the friction. Engineers need access to build. I need access to a database in order to test whether or not my API is working, for example. Very simple example there, but Engineers test, debug, and deploy on a regular basis, which means they need access to some production systems, sometimes databases, managed services. If you're an infrastructure engineer, DevOps engineer, you need access to infrastructure APIs and platform APIs to understand whether or not your deployment works, even if you're testing locally. So it doesn't matter what you're building, if it's applications or infrastructure. You need access to other APIs and systems. Tracking human interactions is easy in some situations, but a lot harder in others, right? So we typically rely on audit logs from cloud providers and audit logs from managed services, right? Datadog has audit logging as well. So all of these things you can ingest, put it into your security information events, monitoring systems, and have some alerts on them. But one thing that I don't see as often, and maybe we should do a little bit more of, is audit logging from secure access management tools. Secure access management tools tend to only happen in larger environments, but if you are working in a larger environment with plenty of scale, with lots of people testing different endpoints across your systems, well, you're going to need one place to audit and understand human interactions with those systems. So let's take a look at this. For example, database automation, right? If you've got hundreds, if not more, of services, right, in one group of people who are trying to develop one of them, you need to know, well, who's accessing a database for some kind of local testing, right? Unit testing, et cetera. So what we're going to do is audit a local connection to a database. Now, we're going to talk about secure access management tools, but I'm not going to go into specifics, right? The one I'm showing today is Boundary, which is an open source one, but at the end of the day, it's not necessarily about the tool itself. It's more about the workflow. So here, what happens is that an application developer authenticates to your secure access management tool, right? Again, one layer of automation for a dev to go in, look at it, and get the information. Now, they are trying to load a bunch of information into the database. It's already loaded. So you don't have to worry as much about that. But the important thing is that if you have one layer of automation to track a human interaction, what this means is that you can track a session or a connection or information about how someone's interacted with that system. This seems pretty intuitive from a security standpoint, but if you're an engineer or a developer and you're looking at this and saying, like, does this matter? The answer is yes. Actually, it gives a lot of information about how you're accessing the system and when you're accessing it. And more importantly, do you really need access to that database system? So in this case, I've already loaded the data into the database. I could go into Datadog logging and look for exact information on whether or not this user has logged in, what kind of session ID they have associated with it. I can get information about that and extract some more information from a security standpoint, but also just from an access standpoint. So it's a way for me to think about, okay, do I really need access to this database? The answer seems like yes. Does my team need access to this database? Yes, based on this user ID, it seems like I'm actually using it. Now, if I grant someone access to this database and they never use it, well, that's a reason for not having access to the database, and you can revoke that access accordingly using a secure access management tool. So the idea is that holistically, you're able to extrapolate all this information, and it is from audit logging. But the only way that you're able to get information about a user connecting to any arbitrary TCP endpoint for local testing is through another layer of automation, which, sorry for everybody, unfortunately, it means you have to have that extra effort. But it's sometimes worth the extra effort, especially if you have a lot of these endpoints in your system and you need to be able to track who's connecting to them. So whether it be across databases, Kubernetes, and more, good to think about. Now, the question that I get a lot is, well, how do I know that this event is fine, right? For example, if someone is using this system or they're trying to access this database, is this okay, right? I don't know if it's good or bad. Well, the point is, with automation in place, you have the ability to identify and block unauthorized access to a system as well. So in this situation, what happens is that an application developer might want to SSH into a virtual machine, which we don't necessarily allow all the time, right? They may not need access to, let's say, a managed Kubernetes node. And so this application developer says, all right, I'm going to try to access this EKS node, specifically this Kubernetes node. And when I try to SSH into it, I get a 403 forbidden. The only reason why this probably works is because there's actually a layer of access management in front of it. And that's why when we actually look at logs, when we actually look at the metrics coming from this, telemetry coming from this, we have the ability to backtrack and reverse engineer. Okay, someone did try to access the system. And we can say, do they really need access to the system? Is this something that we escalate? Is this something that is more suspicious, right? So rather than pausing everything and saying, here's a real problem, we have to fix this, we have the ability to say, okay, this maybe isn't really a problem. They didn't get access to the system, but maybe they do need it. So it's a conversation to start with the developer again. So the idea is that this is a good way to collect information and build a feedback loop on the kind of access that someone needs from a local testing standpoint. And one of the only ways to do this tends to be adding more automation in place in front of it. So next is integration testing. Integration testing is a little bit more difficult to talk about because it's all about service to service interaction. And there's a million ways in which services speak to each other as well as communicate to each other and interact. Auditing service access is a little more complicated because services actually have the same kind of access as a human user. They need to test, debug, deploy, right? If you're doing integration testing for microservices, for example, you only need a certain subset of microservices. Sometimes you need more. But for the most part, you only need a subset. So you're going to have that ability to test that subset, and you need the minimum amount of information for it to work, right? So maybe they need access to some databases, but not all. Some production applications that they interact with, managed services, infrastructure APIs, platform APIs, same thing. But again, how do you know what access it needs? You don't, unless you collect that information. So tracking service interactions is a lot harder. It's not a matter of audit logging, right? Audit logging isn't quite the right term for this. There's about 4 different kinds of sources that you can use to extrapolate how services interact. Access logs, traces, authentication requests, and network flow logs. Access logs come in the form of if you have an auth server, for example. It's a lot easier. If you're using something like Spring, you've got a framework with an authentication server in place, there are access logs available. If you've got something like a proxy in front of things, it has an access log available telling you how clients are connecting to a service. But then there's the other part of this, which is how do you tell services communicating to each other? And that's tracing. Tracing is a lot harder to implement, but if you do have it in place, you can use it to recreate service interactions. And you can do it not just for observability, but also for security visibility. Authentication requests are also very interesting. It's whether or not services can authenticate to each other. In this world right now, we have a lot of other kinds of security protocols and workflows in place. So for example, an application might use OIDC, right, to authenticate to other applications or services. So authentication requests are another way that we think about tracking service interactions. And finally, we have network flow logs, which everybody laughs at me whenever I talk about network flow logs. I come from a networking background. But we still have to use them for some purposes in order to properly reconstruct what's sometimes going on in a network system. We don't always have the luxury of metadata being added. So in some ways, we have to go to the most primitive form of reconstructing what's going on when you track a service interaction, which is the IP address. So today I'll show tracing as well as authentication requests. And the reason why is that a lot of these pieces, you'll have automation across a lot of different tools. Unfortunately, there's not one tool to rule them all in this space. You're lucky if you get an authorization server across all your applications. If you make the effort to standardize, then perhaps you have that visibility. But if you don't have one tool or one system that you're putting in place, one abstraction that you're putting in place, it's really hard to do this. So we're going to talk about one type, which is, well, a service mesh. A service mesh, people are, buzzy, we'll talk about it. But at the end of the day, a service mesh does offer another layer of automation on top of things so that you have the ability to add metadata that you need. So we'll talk about traces as well as authentication requests in the context of an infrastructure layer like a service mesh. If you're not as familiar with a service mesh, that's okay. The idea is that all the traffic is funneling through what is called proxies, right? And these proxies are controlled by a control plane somewhere. You can name your control plane. And this control plane appends valuable metadata to the information and the traffic happening between the proxies. And that metadata is what is important. That's what we think about when we talk and we look at standardizing event information specifically. So service automation, APM. If you're already using APM, you probably have this ability to reconstruct your service interactions. So in this case, I have report connecting to expense, right? Report collects, well, expenses into a report. We're really creative here. But report collects all of the expenses. And what it's doing is that we know report always connects to expense. We know that the report API always connects to the expense API, and we don't plan on changing that. Over time, this is how it trends. This is how it's going to behave. From a higher level view, we're able to say all traffic goes from an API gateway into the report service, into the expense service. So we have all this valuable information for us. And we have the ability to control the network policy between all of them. So we have the ability to say, okay, hey, API gateway is allowing traffic to the report service. Report service has allowed traffic to the expense service. And this is part of what information we get and we can control through the service mesh. More importantly, when we have these proxies in place, the proxies are adding metadata, important metadata, about how these services are interacting with each other. So irrespective of whether or not the services have the perfect instrumentation, right? They have tracing spans, customized, everything else. You get, with the service mesh, you do get additional metadata out of that. So you don't necessarily have to add detailed spans within the instrumentation of your application itself. So in this case here, it's getting a request through report service. It's handling the request, and that's passing it through the proxy first. And the proxy is appending valuable information about how it's going to the outbound or upstream service, like expense. So you'll notice there's an egress proxy. That means it's going from report to the ingress proxy, which is expense. And you get all this additional information, which is nice. Now, if you've got Datadog and you're adding the instrumentation for APM in there already, well, you get this information, you even get the language like Go, etc. But with the proxies themselves, it helps when you don't have instrumentation in your application, or you have perhaps an older application that isn't able to have the proper instrumentation in place. So, that's interesting. All right, let me pull this up again. All right, so what does this matter, right? Like, why do we think about this from this, at least from this perspective, right? Well, it's a way to track anomalous access between services, right? Because at the end of the day, when someone is using a proxy or someone's using some automation layer like a service mesh in place for tracing, you have the ability to identify whether or not there's an anomalous service interaction in the first place. And this is something we saw a little bit today, right? If you have this trend over time of saying only report should ever talk to expense in my integration testing environment, that's the only time that it's ever talked to another service. Why is it talking to reconciliation? So you'll notice that right now, report for some reason is now communicating to the reconciliation service. This could be a new feature. This could be something more, more suspicious. We don't really know. So what we'll do is we'll take a look at it. And from a security standpoint, rather than pause everything and say, okay, stop, we don't know what's going on, we can proactively identify that this is perhaps an anomalous, some anomalous behavior, and we can shut it down, right? So for example, here the proxy itself gives us some valuable information. It looks like someone connected the reconciliation application up at a certain time, and there were some intermittent errors in the middle of it as they were trying to configure it. And it looks like someone, in terms of testing, was doing this out of band, right? They weren't actually doing this as a part of maybe an initial feature, but you'll notice that in the mesh itself, it's saying, hey, it's connecting to a lot of weird things right now. This isn't quite right. So what you can do from a security standpoint is block the traffic to reconciliation, whether you do it in Datadog or your service mesh itself. And then what you'll do is allow the system to run. Now, if this breaks your system, you know that at least it's broken in the integration testing environment. But you didn't let it go to production at least. So you can go and figure out whether or not this is necessary as part of a new feature. But you get a lot of valuable information, even from a security standpoint, using APM. Okay, so let's talk about another thing in integration testing. And I think this is probably the most important one that we're going to talk about today. Secrets. It turns out access requires credentials. Who would have thought? Access is about identity, and typically we tie identity to credentials, right? So secrets provide access. Secrets are anything like usernames, passwords, etc. And they're actually a very good way to reconstruct and audit how people access systems, turns out. Database access is one example we'll go through today. But tracking authentication requests is another part of service interaction or your integration testing, right? Does it need access to this database? Does it need access to some other third party? Don't know. But the idea is that if you have the ability to track, there we go. Okay, if you have the ability to track secrets and how they're being used in your environment, you have the ability to reconstruct service interactions across systems that don't necessarily have instrumentation. So if anybody's tried to put instrumentation on a database, it's a little bit tricky, or a legacy system, also a little tricky. But could you track how someone's using a credential? And the answer is yes. So in this situation, we're using a secrets manager, which is basically a centralized secrets store. And we're tracking whether or not the application has access to the database. This is using HashiCorp Vault. But the idea is that in this situation, because we've turned on access logging for the tool for another layer of automation, we have information and metadata about how it's being accessed, when it was accessed, what operation it was using. So here it's reading from the database product credentials product rule. So that means that it read database credentials for a product database. And it tells me when it happened as well. This is valuable information to me because over time, we know that this application is always going to be accessing this database, right? We can build a history using logs as well as all this telemetry that we might get to understand, all right, this system is always accessing this system using these credentials. Now, if it changes, we know that something has changed in our automation or there's some work or feature that's being done. And having a visibility into that when you have hundreds of services, if not more, thousands of services, is very valuable to tracking whether or not this application should be even accessing this database system in the first place. Now, production. As I mentioned before, we talk about production a lot. Production is the one that we talk about in terms of security because the stakes are really high. And that means auditing even more automation in the first place. When we talk about auditing more automation in production, production access involves whatever happens from a local view as well as what happens from an integration view. So it's a combination of the two. So any techniques you learn in local testing also mimic whatever you do in integration testing, right? The difference though is local testing in production requires temporary operational user access. This is where it gets complicated. How do you grant someone temporary access to a production system? Well, it usually involves asking someone else and then asking someone else and then temporarily getting the credentials and then hoping that no one uses the credentials later. With integration testing, it's a little bit more similar to the normal integration testing environment, right? Where you have a dynamic service access situation. You can understand the history of how services access each other. But the local testing one, complicated, right? It turns out production interactions are about the same, right? You do want audit logs from providers. You want the audit logs from secure access management tools. You also want the audit logs from secrets managers because you need to know how those authentication requests are happening between services. But back to this local testing thing, temporary operational access. That's not really observability, is it, right? I mean, at the end of the day, what we're talking about is saying, if we have an incident, I want to give someone temporary access. That's more actionable. That's not necessarily something we need to observe, but it's nice to have that in place, right? So the thought is, all right, why don't we put together some kind of event-driven access control? This maintains least privilege. It means we still have predictable interactions from a human to service interactions scenario. And we can use automation, once again, to offer temporary access. So for example, in the case of Datadog, you could declare an incident. You know, we saw workflows today. The idea is that maybe this incident says there's a active status, right, going on. And you can use a webhook to contact your secure access management tool and create a temporary role with access to production. Temporary is the key. Don't expect it to have, you know, 4 or 5 days worth of access unless you absolutely need it. But this means that your secure access management tool handles the authorization of engineers to open sessions over this temporary window of time. And guess what? You already have all the auditing in place for it. So you know exactly how long someone spends before you close it, right? And so in the case of Datadog, maybe I have an incident in which product API can't connect to database. what I've done is that I've passed in some attributes, one of which is a project ID associated with the group of infrastructure or service resources that I need access to in this incident. And then I have that webhook. Oh, this clicker. My goodness. All right. We're going to go through the clicker once again. And then what happens is that during this situation, I have a notification that goes off, sets off a webhook, passes the project identifier to my secure access management tool, and using an API, sets up a temporary role for the duration of that incident. When I resolve that incident, it automatically goes through a webhook, and that webhook deletes the temporary role with access to production. So sounds complicated, right? It is automation you have to implement yourself, but it is possible. And what it's effectively doing is combining the requirements that you might have for production, for maintaining least privilege at a given point in time, and doing it ephemerally, right? You're not granting more access. Now, if you do want to grant more access because maybe there's a long incident that's happening, right? Or you have to pass off to other people, in which case, you can have some additional automation to extend the number of sessions that you have open, or who's accessing certain infrastructure. But the idea is that all of the revocation, as well as the creation of a temporary role for an incident, is done through the incident lifecycle. It's not done outside of it. It's not a permanent thing. So secrets provide access. We went through this before. And so auditing usage of secrets becomes very important in production, especially because production has a lot of automation in place. And I deviate a little bit from the application deployment scenario a bit, but think about it this way. People run a lot of infrastructure automation. They build infrastructure a lot. In fact, all the time. For me, I do a lot of deployments through Terraform, and it's kind of hard to track your Terraform deployments unless you centralize them in one place, right? So we use, let's say, version control to track, okay, Terraform apply. You make sure that it's actually being created properly. Your plans are probably getting tested just to make sure no one's putting in some misconfiguration. But what about automation that's really automated, meaning it's constantly reconciling? So in this case, I have some Terraform that is constantly running, meaning it's not push-based. I don't push and then it runs. It means anytime, let's say, a value changes, Terraform runs in response. It's all fully automated. How do I automate this and also get some visibility into when it runs? Well, this is where audit logging comes in place. And this is where it's actually really neat because it's using Secrets Manager, it's auditing the secrets usage. So every time this automated piece of Terraform runs, it's using a secret from Vault. And the Vault audit logs reflect when it's being used. So some of the logs here you'll see includes the Terraform configuration retrieving a static key value and using it right later. So I'm able to audit whether or not this Terraform has accidentally compromised this key value, something, or database password, or who knows what. The idea is that even for the most automated scenario in which you have automatic reconciliation, if you're auditing at least secrets usage as well as credentials, you have the ability to continue to reconstruct the service interactions that you have in your production environment. And we could get even more complicated if you want. You can even get with certificates, for example. So in the case of certificates, you might say, you know what? I have a bunch of certificates that I want issued by a secrets manager. And now I need to track whether or not those certificates were issued at a certain time, at a certain date, who they were issued to, why they were issued, in what manner. So in this case, you'll notice I have a lot issued to an API gateway. The API gateway actually has a certificate rotation of 20 minutes in this scenario. So you can imagine it's a very short rotation, but it's good to understand that, okay, there's a lot that is happening with these certificates. They're being constantly rotated. And I know that when they're going to be issued at what cadence and what access. So in this situation, I have the ability to update the gateway's certificates and then ultimately audit what's going on. So I can look at the audit logs and I can reconstruct, let's get through this, reconstruct that it was an intermediate certificate issued to this gateway and at what cadence and when. For other certificates, you use certificates in a lot of other ways. More and more, we're using certificates for other distributed systems in our environments as well. Having one central place for auditing how those certificates are issued is also really useful. So in this case, you'll notice that I had an intermediate CA. And I was able to issue certificates throughout that intermediate CA to what is a service mesh. So you can even audit your automation, your own automation with more automation and more automation if you really wanted to. But the idea is that it's giving me a holistic picture of all of the things that are happening in my system. If I've spent this much time automating and building all of these systems to work seamlessly with each other, from issuing certificates across various controllers, various scripts, automated environments, why not have the visibility into it as well? It means consolidating and understanding what kinds of systems and audit logging you have available across your automation. So in this case, you'll notice that I had some information about issuing a certificate to that target remote address. So 172.25.26.137. That's a very powerful way to reconstruct when a certificate was issued, where it was issued, and to what node. So, all this to say, really what we're doing is very simple at times. Really, sometimes all we want to know is whether or not some system has root access to a static secret. So it could be that someone went in and they managed to reconstruct a secret to a database, right? And we have to ask ourselves, is this normal? Is this fine? Well, if we have temporary access or event-driven access control set up, and they're only allowing temporary access, then this isn't so much of a problem. And in which case, this would be an anomaly, right? Someone is accessing a static admin database password, and they're maybe not supposed to. And in this case, I have the ability to reconstruct what kind of token was being used to retrieve it, how it was being retrieved, what path, when it was done. And all of this information is helpful, especially if you know that it's supposed to all be automated, right? You're not supposed to have one-off tokens accessing this. And you're going through other systems, right? You should be seeing metadata tagged from other automated systems. So in summary, automation requires a lot of access, right? And it comes down to auditing what kind of access everything has. And when you think about other use cases, we talked a lot about application deployment, a little bit about infrastructure, but this applies to a lot of other systems that you have. Controllers, anything you have to do with GitOps even, as well as managed services. Some managed services are a little bit easier at times because you can just say, turn on the audit logs, funnel it to a target system or a sink that I want. But all the other ones we don't really think about. We don't really think about auditing what our controllers are doing other than by examining the logs. And from a GitOps, when you're using a GitOps flow, for example, you're really thinking about the user experience of someone pushing something and something reconciling those changes. You don't really think about how much access that system has to other things. So just to recap, why are we auditing the access? Well, let's think about it this way. Observe your service interactions, build a history of it. It's a good way to understand what is happening in your system and identify what's potentially anomalous. You can maintain least privilege. At the very least, you have the visibility to understand what is your maximum access and what's your minimum access. And you can more easily identify and mitigate that blast radius because you have the standardized event information, you have the right metadata in place. And if you really want to get very, very specific with kind of how you respond to these things, then you can do custom rules in Datadog, set them, create an incident, open it up, create a temporary access for someone to resolve that in the system, and then go back. So you have all these options available to you when you have an end-to-end observability system. Now, time of resolution, we've looked at this from, all right, we fixed the automation. That is a fixed capacity. We know what that effort looks like. But we didn't really look at the effort for identifying the security issue and recognizing and remediating. Hopefully this kind of narrows and reduces the time for these stages. The point is that the more information and metadata that you're collecting about the automation itself and what it's accessing, the easier it is to reduce the time, to identify the security issue, and remediate what's potentially going on. And if you're curious to learn more, there is a big example. This is a working example and demo. You're welcome to reconstruct it. It is on GitHub. Feel free to check it out, examine it. It does a lot of end-to-end infrastructure deployments, and it's completely automated. It has a combination of a lot of different tools in place, as well as funneling all of this information to Datadog. And if you have any questions, you can always reach out to me. Thank you.
We have, because it's the break, we have time for questions. Maybe some questions. If you have questions, just please stand up and go to one of the mics.
Well, thank you so much for the talk. One quick question, could you move one slide back? I'm guessing some people still need to take pictures. But one thing, so you were mentioning automating that access or granting. So I was kind of thinking, well, that would be great if the only time I grant access is during the CI/CD deployment. But if I'm doing that during that phase, if the attacker actually gets access to that system, what's the difference of that account always being on or only getting kind of that automated access created during execution of that flow? And I think to some degree you answered that by saying, well, if whatever it's doing during that flow is maybe unauthorized or out of its realm, right? So you said expenses weren't or report wasn't talking to expenses, started talking to reconcile, so you kind of noticed that. But how do you know what are those new features that were being introduced? And again, maybe it's because you've detected it in dev before it went to prod, and by the time you've gone to prod, you were supposed to be informed. But then how do you automate that? Because obviously that's a manual process of finding out what did the developers do, or do you have some kind of way of saying, I detected it and manually intervened in dev, but now prod, listen to what I did there and make sure you don't repeat that stoppage or whatever?
Yeah, that's a great question. Part of this is adding the right kind of process in place and metadata in place as well. It's the discipline of it is hinged upon, and this is the good news about development now. We have the discipline of assigning the code we commit to features, right? And that's the easiest way to do it right now, right? Which is to say, okay, this is directly related to a feature. It's not an anomalous activity. In terms of manually investigating or gaining visibility, it's a lot easier for me to look at a commit message and say, oh, this is actually part of a feature. And in which case, ignore that rule, or it's not actually anomalous. This is the new normal going forward, and you can flag that in observability system that you might have, right? You can say that's a new normal because I recognize this as a valid feature. Other times, if you don't have the development discipline that actually correlates a feature or an updated change with one of these things, then unfortunately, it becomes a lot harder to assign it as a new normal, for example. That is still a fairly manual process. It does require tracking down who made the change or what changes are being made. And if there's something that is going to go in perpetuity, right? And so some folks, the way that I've seen this happen in a couple different environments, they have two sets of environments. They have dev, they have staging, and they have prod. And anything goes in dev, right? They're okay with all of these different interactions, et cetera. Staging is their baseline. Because anything that goes to staging is what's going to production. And so they establish the alert in staging, and then they establish the alert in production. But most of what happens in dev becomes sort of a push model of saying, this is the kind of exception I want made. This is a new application called reconciliation, and it should be connecting to report and expense. So basically, part of this is combining better audit information from the actual development process, as well as separating this by multiple environments. And it comes as part of the development lifecycle, unfortunately, not as much as part of additional automation. Hopefully that answered the question. What else? Okay, thank you, everyone.